Okay. Morning all. I hope you're all well. Welcome to week 11 tutorial. Coming towards the end of the semester, business end, and you must all be gearing up for exams, assignment submissions, and this is your project for MM101. I know that the change in teaching method and learning method, going fully virtual because of COVID, has not been ideal, and it's not been ideal for anyone, but I'd like to congratulate you all on making the most of the situation and carrying on to this point. So almost there. Don't lose hope. Don't give up. Just a few more weeks of hard work and semester one will be over. So this week's tutorial, we're looking at sectional views. We're given an object in tutorial 9. Obviously has a shaft with a keyway in it and 2 bolt hole connections, and we're asked to draw the sectional view along the sectional plane given, both in the isometric view as well as the front elevation sectional view. Okay, so similar to last week, how the activity was for you guys to draw the isometric drawing of the 2 objects. This week's activity for attendance is to draw the isometric as well as the front elevation sectional views of this object. Okay. Can anybody just remind us all, what is the purpose of having sectional views? Anyone has any ideas why we have sectional views? Okay, yeah, that's pretty much hitting the nail on the head. Better view or dimension of shapes or parts that are not easily understood from outside views. That's exactly why we have sectional views. I apologize in advance for the audio. I'm just recovering from being sick. So if the audio is not too good, I apologize. But yes, that is the reason why we have sectional views. Okay, sometimes in drawings, we have internal details or internal features of our designs, which cannot easily be seen from any of the 6 principal viewing planes. So the front, back, top, bottom, left, right. Sometimes the details are inside or internal, like in the case of a mechanism. So there is one way that we do show those details, and that's through hidden lines. Hidden lines are commonly used. Like in this activity here, we have hidden lines in this side elevation, where you have the hidden lines, but it's not always clear as to what the hidden lines are showing. Okay, in this case, we have 2 hidden lines side by side each other, and we're not sure. I mean, we can infer, but it takes a little bit extra work to try and understand or interpret these hidden lines and what they represent. So in these cases, the best option is to do a sectional view. Now, a sectional view is one of the main detailed drawing tools in an engineer's arsenal, and we have to easily understand when is the best time to apply them. So for some of you, for your project, you will require a sectional view. Some of you, like you guys doing the wheelchair, you may need a sectional view to show certain details, but it's not always necessary. Okay, not always necessary to do a sectional view. Some you may prefer to do a exploded view or an assembly drawing. Okay, so it's a case-by-case basis where you apply different detailed drawings. So some of you might have inclined surfaces, with details on them. So you may decide to use an auxiliary view. Some of you may have complex geometries, one-piece complex geometries with internal details. So you may decide to use a sectional view. Some of you may have lots of mechanisms fitting together to create your design. So you may have an exploded or an assembly view. So there's lots of different types of drawings you can have. For your final project, of course, you all have to include some form of dimension drawing. So the most effective is usually an orthographic projection. So that's why we have the orthographic projections, mainly for dimensioning. But you could also dimension an isometric view or an oblique view. There's lots of different types of detailed drawings, and a lot of students have been asking me which ones do we have to include, and my response is there aren't any set requirements for the detailed drawings. You don't have to all do one section, one auxiliary, one orthographic, one isometric. Okay, it's not like that. It's completely up to you guys. You can have 4 exploded views and 1 orthographic, and that would be fine. Some of you can have 1 drawing of each, isometric, oblique, auxiliary, pictorial, exploded, you know. So it's a case-by-case basis, and there's no set requirements. Just choose the drawings which best help to explain your design. But yes, back to our activity, sectional view. For this week's activity, and to get your attendance, you have to draw the isometric view of this section, of this part sectioned along this plane, as well as the front view elevation of the section view. Okay, is that clear for everyone? When you're drawing, you can either use Autocad to develop your sectional view, and I strongly recommend that you do, just so you can have a bit of practice. Or if that's too much or you don't have time, a neat hand-drawn section view would be fine. Make sure to use the rulers, your compasses. It says to draw it to a 1-to-1 scale, but for those of you who can't print out this drawing, and since it's not dimensioned, you can just sort of eyeball it and get basic dimensions. Don't need to be exact. You just have to show us that you understand how to do a sectional view. Remember when you do your section cut to include your hatched lines, 45 degrees, hatched lines, to show that that part is sectioned along that surface. Okay, this isn't a very strenuous activity. You should all be able to do section views, no problem. It's all about 3D visualizing and understanding what the shape would look like if you cut it down the middle and stuff like that. Okay, so do you guys have any questions about sectional views or how to do section views? Any questions? Okay, going back to discussing the project. Group leaders, are you guys happy with the progress that your group is making so far? Ideally, at this point, you guys should be wrapping up your detailed drawings, you know, doing the final finishing touches, making sure that you guys have got all the detailed drawings that you need. Okay, at this point, end of week 11, that's where you guys should be up to, so that next week and the week after, you can be concentrating solely on fixing up your report as well as preparing your presentation slides. Week 14, again, we'll be having a presentation in your tutorial session. The tutorial session will be 2 hours long and may combine the tutorial group from the session before. So the session before this was 10 to 11. So maybe 10 to 11, 11 to 12 combined into one session. You'll all be given 20 minutes to present, 15 minutes for presentation of PowerPoint slides, 5 minutes for questions and answers. In groups of about 4 members, That means you have about 3.5 minutes each to present. Okay, it has to be an even distribution of work. It has to be even amount of presenting time. And the questions at the end can be addressed to individual group members. So make sure you guys understand everything that you guys have presented, as well as all the steps of the design process. Even though maybe one of the possible solutions wasn't your responsibility, understand the rationale or the working function behind that design. Okay. As a group, you guys have to now communicate between each other effectively to divide the work, as well as communicate your findings or communicate your issues to each other. Okay. Next week, I will talk a little bit about compiling an effective presentation, as well as discuss a little bit about your assignment, which is also due in week 14. Dr. Kabir held 3 lectures this week talking about the calculation report and the types of analysis you have to do and the steps and the rationale behind it all. And he explains it very, very clearly in his lectures, which is also almost a recap from his lectures in week 6. So if you missed out, I recommend you guys go back and watch them. They're on Moodle, clearly titled so that you guys can't get lost, or so you know where it is. If you're having issues with this assignment, I recommend you guys go back and watch those videos. But yes, next week we will talk about any issues you still have with the assignment. Some students have been asking whether or not they have to compile the presentation, the calculation report using the calculation sheets given in the assignment handout. And the answer is yes, you have to use the calculation sheets, because that is the professional or industry standard for doing such kinds of calculations. And the whole point of it is to try and get you guys familiarized with the professional standard of doing things. So you have to use the calculation sheets given. Are there any questions? Just another reminder, group participation and making sure everybody participates in the project is a very important thing. And unfortunately, because of COVID, I can no longer do my own assessment because we're not in the classroom together. Not everybody's able to join the online tutorial sessions at the same time. Sometimes they have to watch the recording. That's why we've set up the Viber group for tutorial submission, because some students aren't able to access Moodle at certain times throughout the day. Do we have to draw in AutoCAD for the assignment? I think it's preferred that you guys draw the designs in AutoCAD. But of course, special cases and people who aren't able to do so may hand draw. But you probably should ask Dr. Kabir about that one, since he has the final say. But as a first priority, people should try and draw using AutoCAD. If you actually can't, or your software doesn't work, or you don't have access to AutoCAD, then those are extenuating circumstances, and you guys might be able to submit a hand-drawn solutions. But yes, as I was saying about the project, us tutors, we rely heavily now on you guys' feedback as to how your group is performing and how each individual member is performing in the project. If there are members that aren't pulling their weight, or those who are just along for a free ride, we are relying on you guys to let us know so that we can factor that in when we give the grades. Because it's not fair to you guys, and it's not fair to them, as well as the whole university and by and large the industry, if we let people free ride all the way through. Okay, along the whole process of becoming an engineer, you will come across people who like the free ride, who don't like to put in the work, who are there for a good time, not a long time, who are there just to make the money, but don't really have a passion for it. And you'll be doing them a favor as well as Fijian engineering industry a favor if you point these people out early, so that they can either redirect their attentions to a field where they're more interested, rather than go out to the field and then these guys become dangerous or liability because they just don't have a passion for the engineering field. So group leaders, we are relying heavily on you guys to let us know if you have group members who aren't participating. But for this tutorial session, I believe most of you guys, almost all of you, are very good and working hard. So I really appreciate that. Regarding the project feedback, group members, have you made the suggested changes? Have you guys managed to review your drafts? Okay, good. If you want to send it back to me to have a second look, I'll be happy to do so this weekend. Are there any questions from anybody about the project or the tutorial activity? The presentations will be on Zoom, so they won't be pre-recorded. So make sure that you're all present. Please, if you can, do practice presentations amongst your group members, create a Zoom chat room for you guys and practice using Zoom to present, practice using, the laser pointer on Microsoft PowerPoint. Just a few tips for your PowerPoint presentation. Please don't make it each slide. Try and keep the number of slides down, as well as try and keep the number of words per slide to a minimum. All right, there's two reasons for that. If you have too many words on a slide, it becomes too tempting for the presenter to just read from the slide. And the whole point of a PowerPoint presentation is for the presenter to impart some kind of extra value or extra knowledge when they're presenting. If not, then you would just have to present a report and the person could read. The presenter has to, add a little bit more. So you just put the very basic or the very root information in the slide. And then when you present, you elaborate on it. You can talk more about it. Per slide, you might just have like 20 words or 30 words, not that many words. And the presenter might then talk for like a minute per slide. Just adding a bit more onto what the slide already has and the information the slide already has, sort of ad-libbing and including more information wherever they can. Try and keep the number of slides down, just because you don't want to be skipping through your slides at such a fast rate to try and get through all of them in 15 minutes. Try and keep it so that you have like 30 seconds per slide. That's the ideal amount, 30 seconds per slide. Now, if you do that across, you would have 15 slides. I understand that's a lot of slides. Sorry, not the 15. You'd have about 30 slides, and that's a lot of slides to have in a presentation. So ideally, you would like to have about 30 seconds per slide, and then have about account for maybe 2 or 3 minutes for the interchange or the introduction, or people turning off their mic, people turning on their mic, back and forth like that. So if you can keep it around 30, 45 minutes, 30 to 45 seconds per slide, that would be great. And remember, everybody has to participate equally. So can you explain more on sectional views? I don't quite understand. Okay, so right, let me. Sectional views. So a sectional view is basically just taking a cut and looking at that cut object. Right, so this is the sectional cut plane. So this dotted line shows where the sectional plane is. And we are looking in the direction of the arrows. So the arrows are pointing this direction. We're looking in this direction of the object. So looking at the front elevation. And the cut will be parallel to that front elevation. And it will project perpendicular to your eyesight or your viewing plane. I will just okay, are you able to see my screen? So this is a software called SolidWorks. It's very similar to AutoCAD. Only reason I've developed this drawing in SolidWorks is because it runs better on my laptop than AutoCAD. So this is a three-dimensional object, three-dimensional space. Now, if we look at our activity, the sectional cut runs along, like halfway along its width. And we're looking in this direction, so it's the front elevation. So our sectional plane will be parallel to the front elevation. And we'll move it in towards the center, and wherever it cuts, that's our sectional view. So again, this is our three-dimensional object. This is our sectional plane. You're able to see? And like I said, we're looking from the front elevation, so we're looking in this direction. The sectional line is along the center of the object, along its width. And as we move our sectional plane further into the object, this highlighted blue bit is the sectional projection, or what you would see when you cut the object at that region. Okay. So what you would see when you move the object further in, the sectional plane further in. Now at halfway, or where the sectional plane is in our activity, this would be the isometric sectional view. All right, and then our front elevation would be looking from the front. This is our section. This is hatched lines showing a sectional cut. Okay, what does that help answer your question? Sectional plane is basically just a cut on the object along that plane that is given to us in the drawing. And it's just showing us what the details would be if we were to cut that object in half. So if we were to cut it in half, this is what it would look like. Isn't there an extra auxiliary? There is an extra auxiliary view task, but a lot of I've given it to the students earlier in the week, and they've complained that they don't have enough time for that as well as this and your assignment and your project and other units. So just to try and lighten your workload, I'm just saying to complete the sectional activity and not to worry about the auxiliary view from last week. But if you'd like to send in your auxiliary view just for me to have a look, I'll be happy to do that. I also have to be mindful that you guys have other units to focus on. A lot of you, stretched thin, you're doing your MA, your PH, your UU114 and MM. So just to lighten the workload, I'm just saying, just the sectional view for this week will be fine. Okay, guys, are there any more questions? Okay, guys. Well, thank you very much for joining me this morning. Have a blessed weekend, and I'll see you all next week.